Hello everyone, we have exponential equation on the board. E to the power of 6x minus e to the power of 3x is equal to 1. And we're going to solve for the value of x. In solving this equation, we'll be solving for the real values of x. I'll be using a substitution method to solve this equation. So let's do it. If we take a look at the exponents, 6x and 3x, 3x is half of 6x, and if we divide it by 2, 6 divided by 2 will become 3. So that means it will be the same as the exponent of the second term, 3x. So in here, this equation will be transformed to a quadratic equation, and then we'll be using substitution to represent the value of e raised to the power of 3x. Alright, so let's do it. Okay, so e raised to 6x minus e raised to the 3x equals 1. First term can be written the same way as e raised to 3 times 2 multiplied by x minus e raised to the 3x equals to 1. From here, we focus our attention on the first term of the equation. So let's isolate that over here. A to the power of 3 times 2 times x. This could be written the same way as e raised to the power of 3x multiplied by 2. Or this could also be written the same way as e to the power of 3x raised to the second power. This version will be replacing the first term. The first term now equals e raised to 3x squared minus e raised to 3x equals 1. The equation is now transformed into quadratic equation because of the exponent on the power 2 right there. Alright, so now let's start doing the substitution. We're introducing a variable to substitute for the value of e to the power of 3x. So in here, I'll be using y. So let y be the value of e to the power of 3x. And the equation now becomes y squared minus y, and transposing 1 to the left side, it will become negative 1 equals 0. This equation is really familiar one, and finding the value of y by using the quadratic formula, the value of y will be what we call the golden ratio. So we're using a is equal to 1, and b negative 1, and c is equal to negative 1. And using the quadratic formula, y is minus b plus or minus square root of b squared minus 4ac all over 2a. And from here, all we have to do is substitute the values of a, b, c to the quadratic formula, solve for the value of y. So y now then is equal to minus b, where b is minus 1 actually. So that's minus 1. So minus negative b, that's 1, negative 1, plus or minus square root of b squared minus 1 squared minus 4a is 1, and c is negative 1. So negative 1 divided by 2 times a is 1, so just 2. So simplifying this, alright, it will arrive at a value 1 plus or minus is square root of 5 over 2. From here, we can recall that the value of y is equal to e to the power of 3x. So we're equating value of y, e to the power of 3x, to this amount right here. And so we have now e to the power of 3x equals 1 plus or minus square root of 5 divided by 2. Since we're just after the real solution of x, means the real value of x, we are discarding the negative root of 5. So we will be just after the positive root of 5. We have here now the equation e to the power of 3x is equal to the positive root of 5, 1 plus the square root of 5 divided by 2. So from here, solving for the value of x, we're using the natural logarithm. So we're taking the natural log of both sides. ln of e to the power of 3x equals ln of 1 plus square root of 5 divided by 2. We're putting the exponent as a coefficient. The equation now becomes 3x ln of e equals ln of 1 plus square root of 5 divided by 2. And since ln of e, that becomes 1, so left side of the equation will be just 3x is equal to ln of 1 plus square root of 5 divided by 2. Divide the whole equation by 3. Alright, so we have just x is equal to ln of 1 plus square root of 5 divided by 2 all over 3. And so this is the exact value of x. So this is our final answer. For the sake of computation and checking our answer, so that is now in decimal form, value of x equals 0.1604. All right, to check our answer, what we have to do is substitute this value to the original equation, e to the power of 6x minus e to the power of 3x equals 1. Substituting the value of x, 0.1604, to the value of x on the exponent, the first term becomes, that is 2.618 minus second term with exponent 3x is 1.618. Is this equal to 1? So if you notice, this is 2, this is 1, and they have the same decimal digits right there. So this means 2 minus 1 is 1. So 1 is equal to 1. So this just confirms our answer. So x is equal to 0.1604, or the exact value, that is this. And so that's all for now. And for those new to my channel, I would appreciate it if you can hit the like button and subscribe for more videos. Thank you very much. And I will see you in the next videos. Have a great day, everyone. Bye.